Hello and welcome to Psychology 301 Learning. This is Dr. Williams, and this is the fourth in the series of lectures over Unit 3. And our first one here is, we've talked about contiguity, and now I'd like to talk about contingencies in learning. And so we're going to talk about the relationship between the response and the reinforcer, and I've split this lecture into two sections, part 1 and part 2. So let's start off by talking about what a response reinforcer contingency really is. So we're really talking about the rule that makes the reinforcer dependent on the occurrence of a target behavior. So when there is a contingency present, we're usually referring to the fact that a reinforcer won't come unless the behavior occurs, that there's a direct dependent relationship between the response and the reinforcer. And so the reinforcer really depends on the behavior happening. The only way you get the reinforcer is to complete the behavior. So I'd like to talk about 4 studies that are classic studies that deal with the nature of contingencies. The first one is a study by B.F. Skinner back from 1948, where he studied the development of superstitious behavior. And then I'd also like to talk about a replication of that study done in 1971 by John Stadden. And so he found other things that were really interesting related to the response reinforcer contingency. And so I want to talk about those 2 studies together. Then we'll go back and talk about Marty Seligman's learned helplessness studies. And then finally, we'll talk about a study by Peter Killeen from 1984, where he actually asked the subjects themselves whether or not a contingency was operating or what kind of contingencies were operating. 4 really interesting studies. So let's start with the accidental reinforcement and superstitious behavior study. Actually, Skinner published a book called Superstition and the Pigeon. But before we move on to birds and the laboratory, let's talk a little bit about humans. Humans are particularly superstitious creatures. We develop superstitious behaviors through accidental pairings with positive events. So we engage in a behavior and something good happens, we tend to form associations and develop interesting superstitious behaviors. Things like carrying a lucky rabbit's foot or blowing on dice before you gamble in Las Vegas. Sports have lots of rituals, and team players often do lots of funny things. You might have a pair of lucky basketball socks that you wear every single time there's a game. Or the funny body postures that you see in bowling or golf. Here we see a baseball player with all of his funny little behaviors before he goes up to bat. And I don't know if that's Tiger Woods, but golfers do all kinds of weird things before they will actually try to sink a putt. And usually these develop simply out of an accidental pairing with a successful home run or hole-in-one. So that's usually how they happen. So back in 1948, B.F. Skinner, of course, curious about behavior in general, wanted to study this idea of what happens when you have positive events. He referred to them as non-contingent reinforcers. So things that we enjoy, things that we desire, things that are pleasurable to us. What happens when they come just accidentally? And so he called it non-contingent reinforcement. And his study involved placing pigeons in little operant chambers and dropping food in every 15 seconds. There was no response required by the bird. The bird didn't have to do anything. There was a little food cup, and there was a key light on the wall, and the birds, he just dropped food in every 15 seconds. And so the food was non-contingent on any response. So the food was delivered in a non-contingent fashion. It didn't matter what the birds were doing. And he walked from chamber to chamber and looked at the birds. And what he found was that each bird was engaged in sort of an idiosyncratic behavior he did this for several days, and then after several days they developed these unusual behaviors. One bird might be bobbing its head, another one might be turning in a circle, another one might be standing on one foot, but each bird was very persistent in a particular response. And so Skinner concluded that the behaviors that happened just before the food was delivered were being accidentally reinforced, and the birds were acting as though there was a contingency and repeating those behaviors, which is kind of interesting. So he called the accidentally reinforced behaviors superstitious behaviors. And his basic conclusion was that there is no explicit or contingent relationship needed in order for learning to happen. So the bird's behavior was being modified without an explicit contingency. It was simply being modified by these accidental reinforcers. So based on these data, Skinner came to the conclusion, he claimed that contiguity, closeness in time, seemed to be more important than contingencies between the responses and the reinforcers. So when a behavior is followed close in time by a pleasing or positive event, it's more likely to influence behavior, regardless of whether there's actually a dependent relationship between the behavior and the outcome, that there's actually the behaviors producing the outcome. He said contiguity was more important, and that contingency, when it's there, is good, but it doesn't have to be there. Behavior can still change. Now, he will recant this view about contiguity after the behavior systems approach emerges in the 1960s and 1970s. But then remember, this is 1948. It's a while ago. And he kind of sticks with this idea that contiguity is the most important characteristic of response reinforcer relations relative to contingency. So it wasn't until 1964 that Stadden and Simmelhag, John Stadden, replicates this original study by Skinner. But they got different results. And they did do two things differently. Instead of delivering the food every 15 seconds, they delivered it every 12 seconds. This is probably the result of just having existing equipment with a 12-second tape so that the food would be delivered every 12. Probably not important, but a very important aspect of what they did differently was that they observed continuously. They watched the animals and documented many behaviors, and they did so in a much more systematic fashion. They recorded the frequency of each behavior, and they kept track of when each response was occurring and when it was happening in the interval. So they were much more thorough in documenting the individual responses. And they did find the same idiosyncratic behaviors that Skinner found. However, they only found them in the early part of the 12-second interval. So for the first half, or maybe a little more than half, of each interval, the birds did all kinds of idiosyncratic behaviors. One bird might bob its head, another one might turn in a circle, another one might flap its wing, another might stand on one leg. But as they got closer and closer to the end of that 12-second interval, all the birds began engaging in similar behaviors. They were either looking at the food magazine wall, or they were pecking at the food magazine wall around where the food was being delivered. Here are the data from this study. This is from the Stadden and Simmelhag study in 1964. And what we have here are 12 birds. Each graph is an individual bird. And what you find is you see these different patterns of behavior. And there are three behaviors that you should be looking for. You should be looking for facing the magazine wall, pecking at the key light that's there, or pecking at the magazine wall around the magazine. And they are listed here as R1, R2, and R7. And I've circled all of them. And you'll notice that as we get closer and closer to the end of the interval for each of these animals, for each of these tests, you'll see that each of the tests shows that the behaviors that are dominant at the end of the interval are all behaviors related to food delivery. They're either facing the wall where the food will be delivered, they're pecking at the key in sort of an auto-shaping way, or they're pecking right around where the food is going to be delivered. And so Stanton and Simmelhag decided that although there were other behaviors, let me back up here. Although there were other behaviors, here's R4 and R6 and R8, and there are other behaviors, that there were two main categories of behaviors. The behaviors that happened at the end of each interval, they coined the term terminal responses. And they are species typical behaviors associated with food and associated with foraging. Interim responses are the behaviors that happen during the interim in the interval, from the beginning to the middle of the interval, and they just simply reflect different sources of motivation or a broader set of foraging related behaviors that become focused on the location of delivery, and they change as the probability of food increases over the interval. So those behaviors which are more general foraging related tend to dissipate, and they become much more focused on the specifics of the food by going toward the wall, going toward the feeder, or toward the key. And so they gave them different names. Terminal responses, and I lost my cursor. There it is. Terminal responses here, and interim responses. These are the behaviors at the very end. That's why they're called terminal responses. Interim responses are the more general behaviors, and they occur during the interim, in that interval, before the food delivery gets close. And so Stanton and Simmelhag talked about these behaviors, and they talked about the terminal behaviors in particular. And they said that they appear to be initiated by being in a food setting. So you tend to see these behaviors in a location where the animal gets fed frequently, and they become increasingly likely as the probability of food increases across the interval. And they argued that this was consistent with something that was called the behavior systems approach, which evolved out of the belongingness movement. Now remember that if we go back to Unit 2 and we talk about Garcia and Kohling and learned taste aversion and the idea that some behaviors go together with certain stimuli, certain associations are easier to learn between stimuli that go together, like food and nausea. Well, the behavior systems approach was translated into instrumental conditioning, and they talked about certain behaviors going with certain reinforcers. So behaviors going with certain consequences. This is around the same time in the mid 60s and early 70s when people started talking about making the punishment fit the crime, because they wanted that. They were relying on this idea that certain behaviors, if followed by certain consequences, would be criminals in particular would be better able to form the association. All right, so that's one issue related to response reinforcer contingencies. Here we have no contingencies operating, and yet not only do the animals change their behavior, but they also behave as though there's a contingency between their behavior and these accidental consequences, like having food delivery. Now, what happens if there's the absence of a contingency altogether? What if there is nothing? What happens when nothing we do seems to improve a situation? So you're in a bad situation and nothing you seem to do makes a difference. What do we learn when nothing we do works? So if a contingency means that there's a strict relationship between the response and the reinforcer, then having no contingency would basically mean having no control over outcomes. And so what happens when you do that? What happens when you set up a situation where an animal can engage in behaviors, but it has absolutely no effect on the consequences? So this is what we tend to see as something called learned helplessness if the consequences are aversive. And the name synonymous with learned helplessness is Marty Seligman. Marty Seligman is one of probably the most modern, famous psychologists today. He and Phil Zimbardo are probably the two most famous psychologists Marty Seligman was the Robert A. Fox Leadership Professor of Psychology at the University of Pennsylvania. He is the Director of Clinical Training at the University of Pennsylvania. And in 1998, he was elected president of the APA by the widest margin in history. So he's a very well-known, well-respected psychologist. But back in the 1960s, he was getting his career started. His work was primarily on this idea of learned helplessness. The apparatus that he used was a chamber that had two sides with a barrier between the two different chambers. And he worked with dogs. The experimental dogs, so he randomly assigned dogs to be experimental or control dogs. The experimental dogs were restrained in a harness and given a series of mild but aversive shocks that they can't escape or avoid. So there's nothing they can do. They just are put into a harness and they receive these uncomfortable, mild electric shocks. The control dogs are put into the harness, but they never receive any shocks. Then during the testing, the dogs are placed into this dual chamber that has a barrier in the middle. And one side of the chamber is wired for mild electric shock to the floor, and the other side is not. And if they jump over the barrier, they can't escape the shock. And so he wanted to know how long it would take the dogs to learn to jump. And here's what he found. First of all, the control dogs learned quickly. Oh, let me show you the picture here. Okay, so here is the chamber. The dogs have, this is probably a control dog. So this little guy was harnessed and then released and put into the chamber. He experiences a shock, a light comes on, and the floor gets electrified. And he learns within a trial or two to jump over the barrier into the no shock chamber. However, the learned helplessness dogs fail to learn to jump over the barrier. They run around for about 30 seconds. Some of them lie down and freeze, but they don't escape. And they show a much slower delay in learning this response of jumping over the barrier to escape shock. And they found that if dogs received later with one of his graduate students, Mayer, they learned that if dogs received equal amounts of pre-exposure to shock, but as long as the shock was escapable, the control dogs continued to jump the barrier as quickly as the naive controls. So what they found was it had to do with not being able to escape the shocks during pre-training in the harness that was leading to this helplessness effect where the dogs behaved as though they had no ability to learn how to avoid or escape shock. That's pretty interesting. Here are the results from Seligman's study. This is the percent of dogs who learn to avoid. And the control dogs, it's nearly 100%. These dogs learn very quickly, but notice that the shock dogs, the ones that are unescapable of shock exposure dogs, only about 30% of them ever learn to jump over the barrier. And so the conclusion here is that the inescapable shock dogs, the experimental dogs, have learned to behave in a helpless manner. They have learned to be helpless. And the primary difference between the experimental dogs and the control dogs has to do with the response reinforcer relationship that the two groups have learned. The dogs in the escapable shock condition learn that if they do something, they can escape shock. On the other hand, the dogs in the inescapable shock condition in pre-training learn that nothing they do stops the shock, and so they appear to give up. And learned helplessness has been studied not just in the laboratory in animals. It's been done with rats and with monkeys and with dogs and lots of different animals, but it's also been done with humans. There have been studies that looked at college sophomores, and their fingers are strapped onto a little device that delivers inescapable shock, and then they're put in a position where they can, where they put their fingers in a box and are told, keep your finger there, and they do. They allow themselves to continue to be shocked, even though the shock is being predicted. The control subjects who are strapped into the little finger apparatus but not shocked and told to put your finger in the, and then later told put your finger in this little hole, when they learn that a light predicts shock, they pull their fingers out. But the experimental subjects don't. Now, I did this a few years ago with college students using impossible anagrams, and discovered that given enough experience with impossible anagrams, when you provide college students with solvable, difficult but solvable anagrams, they don't even try. Whereas the college students who don't receive that pre-training with inescapable, impossible anagrams, they might miss some on some pages, but they continue working. So they're more persistent. They've also done research on college students using inescapable noise. And so there have been lots of studies that have looked at learned helplessness, and it appears that experience with inescapable aversive events tends to reduce the rate at which people and animals will learn new escape or avoidance behaviors. All right, I'm going to stop here because I want to pick up with a second talk where I'm going to talk a little bit more about learned helplessness and the theories that underlie it, as well as a more study done in the 1980s by a professor friend of mine. So I'll see you back in the next lecture.